This is my desk, and this is my PC. For years I've been leaning down to turn it on, but today that's about to change. I'm going to design an external button which sits on my desk. Let's get started. I know there are other ways to remotely turn on the PC, but nothing beats a physical button dedicated to this simple task. The button is designed to be simple, easy to print, and have the potential to be further improved. You have two options, either connect it directly to your motherboard or through an Arduino. The latter is highly recommended, as this enables the breathing effect of the LED and the other hardware and software improvements which may come in the future. The button consists of 4 3D printed parts and one acrylic disc: top cover, main body, LED module, acrylic disc, and bottom cover. It is recommended to print the top cover first with a layer height of 0.15 mm or better. The top cover is very thin. Take extra care when removing it from the print bed. Next, you can print all remaining parts together. Recommended layer height is 0.2 or better and 15% infill. You can find link to all parts and the BOM list in the description. For the acrylic part, you can either order a pre-cut disc from internet or your local store, or cut one using a circle cutter. If you go with the latter, a 2 mm thick acrylic sheet, and if you order a pre-cut one, a 3 mm thick disc is recommended. The diameter of the disc is 60 mm. You may use sandpaper to remove the roughness around the disc. 2 steps of K80 and K800 gives you a satisfactory finish. To fix the disc to the bottom side of the LED module, use a glue which works best with plastic. To protect the bottom side of the acrylic disc from scratches, stick the bottom cover to the disc. It's very important to use the right glue for the bottom cover. Do not use the same glue as mine or it will ruin your cover. The main body is designed to accommodate a standard button. It sits tight, but as the button will be subject to pressure, use a small drop of glue to fix it. Do not let the glue to touch the pins. Use a multimeter in continuity mode to find the 2 pins which are shorted when you push the button. Pass a cable about 1.5 meter long through the slot on the main body and make a knot so that it cannot be pulled out. Then solder the cable to the pins you have previously selected using the multimeter. I'm going to use male DuPont connectors for both the button and the LED. Use 2 colors for the LED and a single color for the button. It's important to isolate the solder joints. If you don't have heat shrink tubes, use electrical tape. Originally, a 5mm LED fits the LED module, but I'm going to use one that I've taken out of a broken torch. Fix the LED with tape or glue if needed. Now that we are done soldering, it's time to add some more glue to the button. Rotate the LED module counterclockwise 3 times before closing it so that the cables are not twisted when it's closed. If you have done everything right, you should now have 2 cables, one for the LED and the other for the button. Option 1 is to connect both the LED and the button to the motherboard's front panel. Please note that your front panel is most probably different than mine. Option 2 is to connect the LED to an Arduino. In this case, the LED needs a current limiting resistor. The green wire is used to sense whether or not the PC is on. We can do that using a single wire if we keep the Arduino connected to the PC by USB cable. You can find a link to the Arduino code in the description. It's very important to put the Arduino in a case, or you may damage your computer or other peripherals around it. If you don't want to keep the Arduino connected to your computer, you need to connect the power LED's negative pin on the motherboard's front panel to Arduino's GND. I've printed 3 top covers: black PLA, wood PLA, and jitter silver. And of course, you can use wood stain to give a more natural look to it. Thanks for watching, and I hope you enjoyed the video. If you did, then don't forget to give it a thumbs up and subscribe for more. See you next time.